Hello everyone, welcome to the MARMoT Lab. So I'm a mechanical engineering student with a specialization in robotics, and I'm very excited to bring you through a tour of this lab and introduce you to some of the work being done here. So today we have the privilege of speaking with Assistant Professor Guillaume Sartoretti, who will bring us through this lab and introduce us to some of the fascinating work being done here. So Prof Guillaume, can you share a bit more about yourself?
Hello everybody, my name is Guillaume Sartoretti and I'm an assistant professor at NUS. I joined NUS 6 years ago and recently I've been part of the organizers of the new Robotic and Machine Intelligence undergrad program. In this program, I'll be teaching robot programming in the second year and likely an elective microprocessor application later in the studies. I'm also the founder and director of the multi-agent robotic motion MARMoT Lab, which focuses on many different types of platform and their interactions and cooperation, and in particular, those Lego robots.
So can you tell us a bit more about the lab?
Yeah, with pleasure. So my lab is called the Multi-Agent Robotic Motion, MARMoT Lab, and we focus generally about two main axes. The first one is multi-agent systems, so usually systems with multiple robots, where we have application for logistics, think Amazon warehouses, traffic, either autonomous vehicles or traffic light system distributed in the city, and also on search and rescue with exploration, mapping, retrieval of victims after disasters and things like this. So it's all about how multiple robots, which can be different, work together to achieve a common goal. On the other end of the spectrum, I love focusing also on those more complex, articulated robots, where I focus on one robot with many joints working together for one goal, usually locomotion or agile maneuvers.
So what about the RMI students?
Yes, for RMI students, we'd love to involve students early on during the undergrad program in the form of, for example, independent studies or just research internships in the lab for volunteering students. And of course, in the fourth year, we'll also be offering final year projects that could also use some of those robots, right? In the past, I've been involving a few students for independent studies, for FYPs, and we've had like pretty big successes of then students going into careers or graduate studies, even overseas. And so I think that students getting involved early can also help them a lot with what happens after the fourth year of the program.
So there's a lot of work being done here. Can you share more about it with us?
Yeah, with pleasure. So this, for example, is Lilith. She's a hexapod, so 6-legged robot. It's a modular one, this one, so we can actually change the configuration, remove legs, add an arm, etc. So it's a very good research platform. And with her, we've been working a lot on bio-inspired locomotion. So here, getting inspiration from animals with 6 legs, so insects, on how they locomote over rough terrain, maybe climb over obstacles, or even stabilize their body. For her, it would be to carry a sensor or a payload. We've also recently gone into legged manipulation. So here looking at using some of the legs at times to locomote and maybe some of the legs to do manipulation. So for example, pick up an object, open a door, pull a drawer, etc. On this end, we have our quadruped dog. So this is multiple robots from different manufacturers. And all of those we're focusing on bio-inspired locomotion, but going a lot deeper into the bio-inspiration. So we're working also with biologists or bio-inspired roboticists around the world on how do animals structure their locomotive system and what inspiration, what mimicry we can get to have robots that can walk over difficult environments, change gaits, or even do agile maneuvers, jump over things, precisely place their feet, or even do backflips and other things.
So now we're in the Control and Mechatronics Lab. So what goes on here and what do you guys do here?
Yeah, so the Control and Mechatronics Lab is a shared space for multiple professors in the department focusing on robotic, mechatronics, applied mechanics. We have people working more on manipulation, underwater locomotion, and the portion of my lab that is here focuses more on our ground robots, and we're also spinning off a little bit into UAVs, so drones, right? And over here, we have our uncrewed ground vehicles, UGVs. So we're focusing a lot on search and rescue, exploration, mapping. So we're working really on more Initially it was single agent, but now it's multi-agent autonomy. So searching through a space that is unknown, discovering the space, mapping it, and maybe searching for targets of interest, victims after an earthquake or a natural disaster. And so we need to first develop this full sensing suite, so having computation, sensing, and actuation, and then working on where should I go? How do I understand what I already know about the space, and how do I share it with other people and develop those distributed but collaborative exploration strategies with multiple such robots.
So thank you, Prof Guillaume, for showing us around the labs, and I'm sure that we've all learned a bit more about robot and machine intelligence, and we hope to see you in CDE.